This is lesson number 1 of quantitative aspects of chemical change. So we're going to begin this lesson by defining 1 mole of a substance, and then later on we want to visualize the amount of things which will be equivalent to 1 mole of a substance. And then lastly, we're going to calculate the number of moles using the conversion between the number of moles and the amount of things that equal to a number of mole to 1 mole of a substance. So now, first things first, let us define 1 mole of a substance. Learners are encouraged to know this definition as it is because it is in line with the examination guideline of CAPS. Now, 1 mole of a substance will be defined as the amount of a substance with the same number of particles as there are in a 12 gram of a carbon-12. Learners are encouraged to know this definition. So now, I'm going to begin this by what we used to say when we were growing up. These have been instilled in almost all of us. We understand that a dozen of things is equivalent to 12 number of those things. So now, just because we're speaking about science here, I'm going to refer to the things as particles or atoms or molecules. So I'm just going to run away from talking about things. But the understanding is the same. So now, in the same way, a dozen of particles will equal 12 number of those particles. So now, this is simply a quantization of 12 number of things. So we quantize 12 number of things to a dozen. And if I have a half dozen, what do we say? If I have a half dozen number of molecules, that means I have 6 number of those molecules, because 1 dozen is equal to 12. So a half dozen will be equal to 6. I think it makes sense. Now, in the same way as we understand a dozen to a number of things, we should understand a mole of a substance. So what we say is that a mole of things should be equivalent or is equal to this number of things. This is a very big number because, as you can see, that power is 23. So we have a lot of zeros and that power is positive. So remember, if the power is positive and big, that means we have a very large number. And if this number is very large but we have a negative power, that means we have a very small number we're talking about. So this is a very big number of things which equal to a mole. So in the same way, a mole of atoms will equal this number of atoms. Again, a mole of particles will equal to this number of particles. Lastly, a mole of molecules will equal to this number of molecules. So that is simply a visual representation of the amount of things which we say are equivalent to a mole. Now, it's been said that this number is very big, such that you will need to live up to over 2 billion years to count a number of things that are equivalent to a mole. So that is a very big number. Also, if we were to have cold drink cans which are equivalent to a mole, it's been said that they will cover the whole surface of the earth to a depth of over 300 kilometers. So let us give a mathematical relationship of a mole. Okay, now this number of things is called an Avogadros constant, and we denote this number of things by Na. So Na is the Avogadros constant, which is equal to a 6.02 by 10 to the power 23. Now, let us summarize this. We said 1 mole is equal to the Avogadros constant. So this is a conversion factor between the number of things and a mole. So if you want to find the number of moles, you can use this conversion factor. If you want to find the number of things, particles, atoms, or molecules, you can use this conversion factor. Just like you were moving from centimeters to meters, you can move from number of atoms, particles, molecules to moles, or from moles to number of atoms, particles, or molecules. So this is the mathematical relationship between the number of atoms, particles, molecules, and a mole. So the Na we understand by now. Na is the Avogadros constant. So in a formula sheet, this will be provided for learners, so they do not need to memorize this number. But I always advise that learners know everything that they are taught. Now, as we continue, the small letter n in this chapter will be the number of moles. It's calculating the number of moles. And then the capital letter N is simply calculating the number of atoms or the number of particles or the number of molecules. The question will specify what it wants. So learners should be flexible to work with atoms, particles, or molecules the same way. So now this is a constant equals to that number. Let us try on a first example to make sense. Calculate the amount of particles present in 2.1 moles of carbon. So now they want the number of particles and I've given you the number of moles. Remember, we can use this as a conversion factor between particles and number of moles. Or you can use this formula to just find the number of particles after substituting the number of moles. Remember, this is a constant. So let me begin by using a formula because a lot of our learners, I think, they do find formulas easier than the conversion factors. Now, we know that the number of moles is equal to the number of particles over the Avogadros constant. I'm saying the number of particles because that is what we are calculating. So this can change to a number of atoms or a number of molecules depending on what the question wants. So now substitution, the number of moles are equivalent to a 2.1. We are looking for the number of particles divided by the Avogadros constant, a 6.02 by 10 to the power of 23. So this number represents the number of particles in this case because we want to find the number of particles. So this number can change to be atoms, it can change to be molecules. So now we can use our calculator to cross multiply and find the value of n. So finally, the number of particles of carbon will be equal to that. Now we understand that we can use this as a conversion factor again between particles and the number of moles. We understand that 1 mole is equivalent to how many particles? It's equivalent to a 6.02 by 10 to the power 23 particles. So now this is our conversion factor. So what are we given right now? We're given the number of moles. I'm going to write the number of moles under 1 mole. So 2.1. And then we are trying to find the number of particles. Remember, we represent number of particles by n. So what you need to do here is to simply cross multiply. So cross multiply. So n finally will be the same amount. If you say 2.1 multiplied by that number, it's going to be the same calculation as above. We will get an answer of, a 12.642 by 10 to the power 23 particles. This is the end of lesson number 1 about the number of particles, number of atoms when we speak of the Avogadros constant.